Okay, so now we want to quickly go through histograms. All right, these are it's a way of displaying group data. Okay, but the group data that we're going to display should be continuous. So when we say group data, it means that it has an interval. So we are not putting our data as in whole numbers, but we are putting as intervals like this to say 0 to 20, 20 to 40, 40 to 50. This is grouped data. It has intervals. We have intervals and not values. Because if I have values to say 14, there are 10 people that are 14, and then whatever, then that is not grouped. But if I put it as an interval, then it becomes group data. Now, when we represent this group data, it must be grouped and continuous. So if you see this, look, I want you to look at the bounds. Here, it is saying 0 to 20, and here it is not saying 21 to 40. No, it is saying 20 to 40. So this is definitely continuous. Then it says 40 to 50 after having ended at 40. So you see, it stops at 40 and starts at 40. So it's not starting at 41. It's starting at 40. So this makes it continuous, non-stop. Okay, and when we have something like this, grouped and continuous, then we can put it on a histogram. Now, a histogram is something that looks just like a bar graph. Okay, like bar charts. They are the same, but they've got some differences. If you look at this, something which is very important about a histogram, the difference between a histogram and a bar chart is that there are no gaps. It's continuous. So the first bar is ending at 20, the other one is starting at 20. So this is there's continuity here, right? Exactly. So histograms are continuous. There are no gaps. And then the other thing is that we have this new word here, frequency density. Okay, for bar chart, we had frequency. Now we no longer have frequency. We have frequency density. Frequency density is going to be the height of your bars. It's no longer frequency, right? Exactly. So this is going to be a new thing, frequency density, and you have to know about it. So those are the two things that have changed. We no longer have frequency as our height or the y-axis, but we now have frequency density as the y-axis. Frequency is now the area of the bar. So if you are to get the area of the bar, then you can have the frequency. It's no longer the height on a histogram. The height is something called frequency density. So you should be able to know that. Exactly. Now, another thing is that there are no gaps. We saw that. So now let's look at more at our data. This is the histogram. Everybody has seen a histogram. Just looks like bar charts, but there are no gaps. And then the y-axis is the frequency density. So frequency is not part of our bars. This is just the area. It's not on the axes. Okay, so we'll have our data, the age in years as their intervals. So we'll have them like this, and then we'll have the frequency density on the y-axis. Oh, beautiful. So now let's look. Let's see more, something to know about these histograms. Okay, here are the differences. Histograms have no gaps. We've talked about it between, and they have frequency density as the y-axis. Y-axis we mean as the height. Okay, frequency density on the y-axis, right? And not frequency. Frequency is the area of your bars. Okay, remember that frequency is the area. Now, we'll talk more about model class, but let me show you something. For this histogram, when we want to make when we want to find the frequency density, let's put that. Okay, when you are dealing with this frequency density, okay, this word density is like the one you do in geography, population density. Whenever we talk about density, if you remember from physics, it was mass over volume. Okay, so density is like mass. Remember that mass tells you how much matter is in a body. So mass is how much. So density is like, we can say it is mass, which is how much, over volume, which is the space. Volume is the space. So if we have a container, we want to find the density, we say how much is in there, and then what's the space that we have. So it's the same thing we use everywhere. Density is the how much over the space. So when we come to statistics, the how much is frequency. So density will be frequency because it is how much, and that is frequency over the space, and the space is the interval width. Okay, How big is the class? We can call it class width or interval width. So here we know it is from 0 to 20. So we'll say 20 minus 0 to be 20. Then here we'll say 40 minus 20 because it's from 20 to 40. Then here we'll say it's from 40 to 50. So we say 50 minus 40, you get it as 10. Here we'll get it as 20 and 20. Here you say 70 minus 50, you get it as 20. 100 minus 70, you get it as 30. These are the class intervals, okay? If you subtract higher minus lower. So this gives you the interval width. And then you say frequency, how much divided by the interval width. So here we would say this 40 divided by the interval width, which is 20, and then you get the frequency density. Oh, how easy it is to get. So if you can put this formula, frequency density, remember it's a density, so it's the how much over the width, the space. The how much is the frequency over the space, the interval width. That's going to be your frequency density. If you want frequency, you just take interval width to the other side. It will be frequency density times interval width. And that's like the area, length times width, isn't it? So you then get the area, that is your frequency. Okay, that's how we're going to get frequency. Now, here's the thing. When you are dealing with, we can deal with some of these. So what you should know is when you get your data being continuous like this, like it's ending at 20, starting at 20, it's so easy to find everything you need. Because if I were to make something, make a frequency distribution table, if we make it bigger so that it has frequency densities, we would say, what did we have here? This was a horizontal one. We'll make a vertical one, right? Age, then so age, instead of writing frequency here, I'll write it right here. But I'm not going to put frequency yet. I'm going to say age. And remember that age, I have it as a range. It was 0 to 20, 20 to 40. So it's 0 less than or equal to x, which is less than 20. Then we have 20 less than or equal to x, which is less than 40. Then we had 40 less than or equal to x, which was less than 50, right? And then we had 50 less than or equal to x, which was less than, should be 70. Yes, 50 to 70, then 70 to 100. Less than 70, then 70 less than or equal to x, which is less than 100. So here is our age, and we have it like this. Now, the first thing I'll ask, is it continuous? Yes, it's continuous because 0 to 20, 20 to 40. So it's ending at 20 and starting at 20. So it's continuous. Great. Now, when it's like that, what are we going to do? Well, we are going to make our class boundaries. So we always want to make our class boundaries, okay? So I'm going to say, here we write class boundaries, okay? Class boundaries like this, the same way we would have made for this guy. So here we have our class boundaries like this, okay? And then here we are having like that inside. This one goes all the way up, but this one is breaking. Here we have our lower bound, and here we have our upper bound. So here, let's say here we have our lower class boundary. Here we have our upper. If you see us saying UCB, it's upper class boundary. Okay. Right. What is the lower class boundary? We say what we always do, since it is continuous 0 to 20, 20 to 40, then there's nothing we change. So it'll be 0. The upper one is 20. This one is, the lower one is 20, the upper one is 40. We don't change anything because it's continuous. Ends at 40, starts at 40, so everything is fine. So this one is 40, the lower, the upper is 50, here it is 50, the upper is 70, here it is 70, and the upper is 100. Great, so now when we have it like this, the next thing which I'm going to put would be the interval width. So it's like this, and then we close it off. Okay, class boundaries. Then here we say interval width. Okay, the interval width. Now we say 20 minus 0, 20, 40 minus 20, 20, 50 minus 40, 10, 70 minus 50, 20, 100 minus 70, 30. There we go. We have it like that. Then after interval width, we say frequency, then frequency density. So let's put those two. We can say here we now have our frequency. So remember, it is H, then class boundary. Then the class boundary, the reason we need it is so that we can get the width Very important. That is why if you go back a few videos, you'll find us talking about boundaries again, making sure you understand them because we will need them to get the width, which is going to be useful for us. Then here we have our frequency now. What is our frequency? We're going to take from the table 10, 40, 35, 30. So 10, 40, 35, 30, and then 15. And then 15. Then we can now say our frequency density. Frequency density. What is our frequency density going to be? It'll be, remember, frequency over class width. So it's going to be 10 over what's the class width or interval width? 20. And what would we get here? Half, 0.5. Then in here, it would be frequency 40 over this 20, and would get it as 2. Then in here, we would have 35 over 10, we'll get 3.5. Then we have 30 over 20, we will get 1.5. Then here we have 15 over 30, we would get 0.5. These are the values, and then we can go like this, then like this. Okay, we go like that, and here the values keep continuing, and we can have our tables. So this right here would be your table, and you're done. We've made a table that has more data, and what you say, what is this table useful for? Well, when you want to make your histogram, you would need this. So since we already have the histogram, it's okay. But if you want to make your histogram, you'd need this. So you should start with this table, be able to make one with class boundaries. Then you remember, because it was age, then frequency, but now you put class boundaries. After age, you put the class boundaries, the interval width, then you put the frequency, then you can now find the frequency density. Okay, class boundaries and interval width. Don't forget that you need this too. Now, one more thing which we wrote here is the model class. How do you find the model class? Well, the model class, so basically in histograms, we don't find mode as a value, but we find it as a class. So it's going to have a range. It is the interval with the largest frequency density, not frequency. It is the highest frequency density. So if we're looking at our graph, the class or the interval with the height, with the one that is highest, that is tallest, that is going to be the model class. So the class that has a bar, that is the tallest. So here it will be 3.5 for this guy from 40 to 50. So we can see already model class is 40 less than or equal to x, which is less than 50. This is the model class. And that brings you to the end. And this is everything you gotta know. And you're done, okay? We'll see more in the next video. Bye for now.